Saxon Algebra 2, Lesson 79. I'm going to be a renegade and a rebel in this lesson, and I'm going to start with part B. There's two parts, part A and B. They're both pretty direct, but part B is really straightforward, and I want to get it into your brain before anything could mess you up. You'll remember that a while back we studied what we called 30, 60, 90 triangles, right? And I told you about a really specific way to think about that. I said imagine an equilateral triangle drawn on its side like a reverse play button. Each of these is 60 degrees, and then the sides are all the same length. And I told you to imagine them as twos, right? That's basic, that's really easy to think about. Then what I asked you to do was to mentally chop it in half. Notice that you created a right angle. This angle would still be 60 degrees because that's untouched by our amputation, isn't it? But this angle would go to 30 degrees. This side would still be at 2. This side that we chopped in half would no longer be 2, but it would be 1. Right? Remember all this? And then this, the length of this side, we would have to figure out using Pythagorean. So I said, okay, a squared plus b squared equals c squared. This is one of the legs. So let's call it a squared plus, there's the other leg, 1 squared equals hypotenuse 2 squared. So then we just do our algebra on this. Subtract the 1. Are you with me? I'm going really fast. But you already know all this. So we found that the length of this side is square root of 3. And from that, we derived this really cool thing called a 30, 60, 90 triangle. And what I'm doing is just drawing everything we figured out, but cutting out the parts that we don't need. This is 30 degrees. This is a 90-degree angle. This is 60 degrees. And the sides are 1, 2, square root of 3. And what I told you was A, memorize it, and B, this is super useful because we can now do trig problems at either 30 degrees or 60 degrees, and all of the lengths of the sides are right there, so we don't need our calculators. We can do these problems just using our triangle, and we're going to get better and better and better at doing that. We're going to be really good. Okay, so that's old news. I already told you all of that. Now what I'm going to do is introduce you to the other triangle we're going to memorize, and this one's easier. I don't want to draw it this way. I want to draw it this way. Okay, this is what we're going to call a 45, 45, 90-degree triangle because these two angles are the same size. Okay, now this one is even easier to memorize the sides because we don't have to do this whole imagine it and then chop it thing. What we do is we just say this side is 1, this side is 1. And you can use Pythagorean, but it's super easy just to remember square root of 2. 1, 1, square root of 2. That's all there is to it. We know all the angles, and we know all the sides, and we can use this in all kinds of boffo ways to solve problems. So let's do these problems first. I'm sorry, that just is so sad. John sometimes orients the triangle. Later, we're going to always be orienting our triangle like this, which is why I drew this one like this. John does some problems now like this, so I'll just go ahead and do it. It's 1, 1, square root of 2. That's so easy to remember. And then these are 45 and 45. Okay, so this is the other triangle I want you to memorize. And we'll use it in the same kinds of clever and entertaining ways. Example 79.4, this is the only one, the only problem related to this. Use similar triangles to find x and y. So John has drawn us a triangle that looks like this. Except his is perfect and mine, oh, mine's just very sad. X, Y, 7, 45 degrees. Okay. He said use similar triangles. Okay, well that's a big fat hint that we're supposed to draw in the matching triangle, and we see it's a 45, 45, 90. It has to be, right? Because it's got a right angle here. This was in the original picture. If it's 45 here, it has to be 45 down there. There's no other way around it. And this guy is 1, 1, square root of 2. Right? That's what we memorized. Oh, it's already in my head. I hope it's in yours. Okay, so now what we can do is just set up proportions. The hypotenuse is what we'll use for our anchor proportion. It's 7 over square root of 2 equals x over 1. That's it. That's the whole answer right there, right? Because x over 1, we can ignore that. And look, what happens if we use the same anchor proportion and do it to set up the y? It's y over 1. Ay, ay, ay. All we have to do now is just rationalize these denominators. So we'll multiply bottom and top by the square root of 2 to clean them up. And we'll get x equals 7 times the square root of 2 over 2. See how I'm just simplifying this so that we have a rationalized denominator. And same for y, it will work the same way, right? Y equals 7 times the square root of 2 over 2. Those are our final answers. And we got them from our super nifty Kino Cool 45, 45, 90 triangle. Fall in love with it, please, as best you can. We'll be using it a lot. Okay, that's the end of part B. Now let's go back and do part A, which is talking about metric volume. And this is kind of a cool thing. In the English system, what we're used to, we usually measure volume as a unit of length cubed, right? So the volume of something would be so many inches squared or feet squared or something like that, right? Well, in the metric system, volume, this is English. In the metric, volume can equal a unit of length cubed, or there is a unit of volume that is equal to that. Let me show you what it is. 1 centimeter cubed equals 1 milliliter. Now, we don't have anything like that in English. You can't take 1 inch cubed and make it be equal to a gallon. I mean, that would be out of proportion, but you know what I'm saying? We don't have a relationship in the English measures that connects a unit of length cubed to a unit of volume. A pint is not equal to 1 foot squared. You see what I'm saying? We don't have anything magical that allows the systems to talk to each other. But in the metric system, we do. And it is so fabulous. 1 cubic centimeter equals 1 milliliter. And then another way of taking this, basically if we multiply each of these by 1,000, we can find that 1,000 cubic centimeters equals 1 liter. Okay, These two little guys are super duper useful in doing unit conversions of volume in the metric system. Okay? Make sure you memorize these. Write them in your book. Pause me right now. I mean it. Right now and go write those. Okay, if you're listening to me now, I'm assuming you wrote them, and I mean it. You better. And memorize them, please. Please, 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 please. Notice these are the same. We just, this times 1,000, 1,000. A milliliter, milli means the root of 1,000. So if you multiply that by 1,000, you get milliliters. Okay, let's use them in 3 lovely examples. Use unit multipliers to convert 14,000 milliliters to liters. Okay, well this one is just kind of, we're just warming up. Okay, so let's write it the way we like it organized. 14,000 milliliters to liters. And what we're gonna do is just underscore this relationship, which we might not have done before. For every 1 milliliter, I'm going to write it over to the side. No, 1,000 milliliters equals 1 full liter. That's just kind of like a side note. All right, so we can use that here and get to our answer in one step. We want liters here, we want milliliters down here. A liter is bigger and it takes 1,000 of them. That's the fact I put right there. So then, that's over a 1. We get 14,000 over 1,000, which equals 14 liters is our answer. Okay? John does that just to make sure you understand this relationship, and I think to remind you of how freaking easy the metric system is. 79.2. Use unit multipliers to convert 4 cubic feet. So I'm going to write feet, 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 to liters. What? We're going from a unit of length to a volume. There's no way to do that in the English system. What we can see is we're going to have to switch over to, we're going to have to break it down to centimeters, and then we'll be able to switch it over to milliliters. Okay, so first we have to go from feet to inches, right? And that's going to be 3 times, because we have 3 dimensions that we're doing. We'll want feet on the bottom, we'll want inches on the top. A foot is bigger, there are 12 inches. Okay, that's good. We're doing it 3 times. So feet, 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 and now we're in inches. The next step is we'll go from inches to centimeters. And again, we'll do that 3 times. And this is actually inches cubed to centimeters cubed, right? And this was cubed too, because we're doing it 3 times. So we're converting it 3 places at once. Okay, so we want inches on the bottom. I'll write them 3 times just to help you remember that it's cubed, because that will be important in a minute. Centimeters, centimeters, centimeters. 1 inch is 2.54 centimeters. These cancel. 1, 2, 3, 1, 2, 3. Now, notice that we are in cubic centimeters now. Our original amount, which was cubic feet, has been transitioned to cubic centimeters. Now, we can go from cubic centimeters right into either this one or this one. We want it in liters, so we might as well use this one. It won't bother us that it's 1,000. So now what we want to do is go from cubic centimeters, which is what we have here, to liters. And this is what's confusing, but also very cool. We don't have to do it 3 times because it's taking a third dimension, or this is one we want. It's taking something in the third dimension and converting it to a volume measurement that doesn't need to be cubed. It's perfect just the way it is, right? A liter measures volume. It doesn't measure length cubed. It measures actual volume. So when we do this, we'll have cubic centimeters on the bottom, and we'll have just a single liter on top. We do not need to do this 3 times. It's so weird. Here's the relationship. 1 liter equals 1,000 cubic centimeters. Now all these guys cancel against these guys, and we're left with exactly what we want. And so our final answer, remember each of these are 3 times, but not this one. So our final answer equals, I'm going to squeeze it into the space, 4 times 12 cubed times 2.54 cubed. Here, I'll do parentheses. Over 1,000 liters. Let me make sure I got it right. 12 cubed, 2.54 cubed, 1,000 on the bottom. The 4 that we started with. Yay, this is the right answer. Okay? That is confusing because everybody thinks we should be doing this 3 times. But because of this magical property of these special units of length connected to volume, we don't have to do it 3 times. We can just do it once. Okay, last problemo. I know, you don't want this to end. You could go on forever with these magical stories that I'm telling you. 79.3. Use unit multipliers to convert 4.7 liters to cubic inches. So we see, okay, we're gonna have to do it again. We're gonna have to go in reverse, right? From what we did last time. We'll go from liters to cubic centimeters and then to cubic inches. All right, let us begin. We'll go from liters to cubic centimeters. Okay, this is over 1. Let's just put it there. All right, I want liters on the bottom so it'll cancel. Cubic centimeters up top. This is the one I do not have to do 3 times. It is special. 1 liter equals 1,000 cubic centimeters, right? Yes, trust me. Trust me, I know these things. All right, and then in our next jump, we'll go from centimeters cubed to inches cubed. Now we have to do it 3 times. All right? So when we use the magical one, we don't have to. All right. Centimeters down here. Inches up top. That's messy. An inch is bigger, 2.54. All right, the liters canceled. Sorry, I didn't do that before. My bad. Okay, and now we're left with inches cubed, inches cubed. So our final answer is, I'll write it down here, 4.7 times 1,000 cubed. No, not cubed. My bad. 1,000 over 2.54. That one's cubed. I tried to confuse you, didn't I? How'd I do? Let me make sure. Yes, 4.7, 1,000, 2.54 to the third. Inches cubed is the unit. Yay! Make sense? So when you use the special one, you only have to use it once. And here is where we used it here. This was our other special place. Yay! This is really fabulous, you guys. It makes me so jealous of whoever invented the metric system because they were on their game. I'm telling you what, they just thought of so many cool things when they put that together. But this is a really magical thing about the metric system that we don't have anything like in the English system. And that's why it's so sort of foreign and weird to us, because we don't have this idea that our gallons, liquids, cups match to inches cubed. It doesn't work like that. And so the idea that theirs does blows our minds. I hope it was enjoyable, mind blowage, and not confusing and painful. All right, that's the end of lesson 79. Don't forget about our friend, the 45, 45, 90. He's so cute and simple, right? So easy to memorize. All right, farewell.